Hello everyone. Let's do the last 7 questions of the September 2022 NET question paper. The last 7 organic questions. Right. So the first question says the intermediate involved in the following transformations are. So you are having this para-nitrobenzyl. Please see if it is PHCH2 it is benzyl. PHTC double bond O then it will be benzoyl. So benzyl chloride in presence of base you are getting this product where they dimerize and you get alkene in between. So of course you will know what is the intermediates involved only when you know the mechanism. So you can see this molecule, this benzyl chloride, has a powerful electron withdrawing group, nitro at para position to benzyl. So if you remove this proton, you get negative charge which is stabilized by this resonance effect. See, this negative charge comes here, this pi bond comes here, this comes here. So that means this proton is acidic to a certain extent because the conjugate base formed after removal of proton is stabilized. So the first step is of course removal of this proton. This is stabilized like that, okay. I should have drawn double arrow, double headed arrow. So and then what happens is, then next step this goes and attacks here and you are getting this, and then again this proton is still acidic because you know it will be stabilized by this nitro group at para position. So second step again this removes this proton and you get this molecule, and therefore this and this one wait, yeah, this one and this one, these are the two intermediates formed. So your answer is option A and B, right? Next question, the structure that corresponds to the following proton NMR spectral data. So you are having proton NMR spectral data. So first one is 3.64, which is singlet and 6 proton signal. Then you are having 2.02 double doublet 2 proton, 1.62 triplet doublet 1 proton, and 1.20 triplet of doublet 1 proton. So basically I am having 4 protons, 4 kinds of protons, 1, 2, 3 and 4. Out of that one of the signal is singlet and 6 protons. So of course it will be with respect to this Me, either this or this. Let me show you why I am saying this too, because A and B has a similar kind of substituent here. It is COOMe and COMe. Here also COMe, so they are both esters. Whereas here the cyclopropyl ring is attached to oxygen, so OC double bond OMe. So here Me is attached to carbon, carbonyl carbon, whereas here Me is attached to oxygen. But effectively both the Me's at the terminal end, they are identical, and because they are identical and beside them there is no hydrogen containing carbon, they all will show as one peak and singlet. So that is done. What else is there? Now 2, 3, 4, 3 more signals are there. So you know how many more hydrogens are there. Each of them is having one, this hydrogen 2, then this hydrogen 3, this hydrogen 4, right? All of them has four other hydrogen apart from those two CH3s, but the signal is only 3. So that should tell us difference between, we will be able to find out which of them is there right now. Right now first thing what should we do is we should try to eliminate 2 of the product, because singlet should give us some idea about which one it is, either it is A and B or it is C and D, C or D rather I should say, yeah, because A and B MEs are same and C and D MEs are same. So what we have to know is, if CS3 is there, I would have written differently, yeah, if CS3 is there it has base value of 0.9, if CS2 is there it has base value of 1.3, and if CH is there base value of 1.7. So try to remember at least this much, you have to remember CS3 has base value of 0.9. Then what it says, if it is next to a carbonyl, okay, or alkene or nitrile or alkyne thiol sulfide. So I know it's tough to remember, but at least 2 things you should remember. Beside, if it is beside alkene or carbonyl, just add +1 to it, right? And what you have to add? You have to add 1.5 if it has to aryl ring or amines or sulfoxide. right? Then you have to add 2 if it is attached next to oxygen. So when it's alcohol or ether, amide, even CONH2, right? Um, yeah, if CH3 is next to CONH2, then also it becomes like that. And add 2.5 which is attached to aryl ether. So if it is simple ether, attach add 2. If it is aryl ether, then you have to add 2.5 and add 3 to it if it is attached to nitro or ester or fluoro group. You know, these three are very powerful withdrawing group, right? And ester through the oxygen. What I mean here is oxygen and then C double bond O, then R. When that way it is attached, then you will be adding 3 values. So now look here, what is there? Here M is attached to carbonyl, right? C double bond O, and to this carbon is attached this methyl. So methyl value is 0.9 attached to C double bond O, so it should be 0.9, 0.9 plus 1, 0.9 plus 1 is equal to 1.9. Whereas here Me 0.9 plus it attached to oxygen of ester, we saw in the last, when it was attached to oxygen of ester or to nitro group, then you have to add 3 values to it. So 0.9 plus 3 is 3.9. So it is very close to your 3.64. So of course what you will be doing is you will be writing 3. You can very easily say it has to be either A or B. You can very happily neglect option C or option D. Now what? Now we have to find out from the other signals. So now if you look here, if you see in A, let us see, compare this hydrogen and this hydrogen. This hydrogen next to it is C double bond O. If it goes this side and sees next to it is looking is another hydrogen and opposite to is UMA. If you look at this hydrogen, it is exactly facing same thing. On this carbon it is attached, there is UME. If it looks here, it is seeing on the same side it is H. If it is seeing this side it is COMe. Very clearly, without any doubt, these two hydrogens are very identical. So it should give one peak. It should give one peak, right? Now look at this. This hydrogen also beside it, it is facing COMe. When it is looking next to it, it is finding COMe. When it is looking little sidewise, then it is finding H. Similarly, when if you look at this hydrogen, on the same carbon it is finding COMe. When it is looking sideways, it is finding COMe. If it is going round and watching from side, it is finding H. That means again these two hydrogens are perfectly identical. So now because both of them are identical, both of them should show as single peak and 2 proton signal. So let us look what is there. So we can see single peak 2 proton signal. So this is the value in which both of them will fit, and it's too close, we cannot find out which of them is having 2.02, and they will be double doublet. Why they will be double doublet? Because you see this is attached to this hydrogen, it is next to the carbon containing hydrogen, so it will be doublet, and this will be again split by, so that should be double triplet, right? That's interesting. One second, no? One second, let me look at it. So I'm not very clear. Yeah, possibly because these two hydrogens look very similar. Because possibly these two hydrogens look very similar. So it's like it's splitting up into another doublet. They are mixing up. Effectively, they are pretty much mixing up. That's what I can guess. Okay. And therefore, this should show as double doublet. So you cannot differentiate with these two. Now, the only thing what is left is these two hydrogens. Now, can we differentiate these two hydrogens between the two molecules, right? So, where are we? Yeah, between A and B, we are trying to see that if these two are same. If these two are same, then it should give one peak. If they are different, they should give two different peaks. And we are looking for that molecule which gives two different peaks because we are having 4 signals. If these two hydrogens are identical, Wait, what I'm saying is, if these two hydrogens are identical, then they will give one peak, then we should have total 3 peaks, but what we are saying is 4. So we have to see if these two are different, or in this these two are different, right? That's our goal. So whichever has different, we know that is the molecule which they have asked. So if you look at this molecule where both the COMe are on one side, both hydrogen here and then here, then what happens? You look at these two hydrogens. Okay, this hydrogen, when looking on its side, what it is finding? It is finding this hydrogen, and other side it is finding COMe and COMe. Whereas this hydrogen, if it is looking on its side, it is finding COMe, and if it is looking at other side, it is finding H and H. Very clearly these two hydrogens are different, so it should show two different peaks, so that should be 4 peaks. That is that will suffice our thing. We know that this is the answer, so A is the answer. Other way to look at it will be, look if these two hydrogens are homotopic or anisotropic or diastereotopic. If the two hydrogens are homotopic, then they are identical, they will give same peak. If they are anisotropic, then also they will show one peak, same peak. Okay, it will not show two different peaks. But if they are diastereotopic, they will show two different peaks. So how do we find out they are anisotropic or homotopic or diastereotopic? What you have to do is just change one of the hydrogens with some other atom. So I am putting deuterium, I am putting deuterium. Now you look if they are exactly same. If they are exactly same, it is homotopic. If they are non-superimposable mirror image, they are anisotropic. If they are non-superimposable non-mirror image, then they are diastereotopic. Now look here, what happens? Of course, it is not same. If I turn it around, let me see what happens. If I turn it around 180 degrees, then what happens? I am getting this. Oh, that was another one. Let us look here. If I rotate 180 degrees, then what happens? This hydrogen comes front, D goes behind. Yeah, if I rotate 180 degrees, then what happens? Hydrogen comes front, D comes behind, so they will overlap each other. But this hydrogen comes front and COMe goes behind. So of course this part is not overlapping. They are also not mirror image. If you rotate 180 degrees, then hydrogen and deuterium, they will become mirror image. But COMe will go behind and H will come front. So they are not mirror images. So they are diastereomers because they are neither superimposable on each other nor they are mirror images. And therefore very clearly these two hydrogens are different and they will show two different peaks because we saw that these two hydrogens are diastereotopic, right? Now let us look at this molecule. This molecule, what happens? These two hydrogens are actually anisotropic. Otherwise also, if you just look at this hydrogen, if it sees in its own side, it is finding one COMe and one H. When it is going other side, it is finding one H and one COMe. Similarly, this hydrogen, if it is seeing on its same side, because it is coming outside the screen, please understand, solid line means it is coming outside the screen, it is towards the viewer. So when it is outside, it is seeing on its side one COMe, one H. When behind, it is seeing one H and one COMe. Same with this also, towards its side it's showing COMe and H, outside also H and COMe. So these two are exactly same, so we know they will give same peak. Otherwise also you can put hydrogen deuterium, just rotate it, you will see that these two are mirror images and they are non-superimposable, so they are anisotropic. So anisotropic protons show single peak. So this should have shown 3 peaks, but it is shown 4 peaks. So clearly this is not the answer. Okay. Next question. The correct IUPAC name of the following compound is. So what happens? See, Cl is never a functional group. Halogens are always just a substituent. So even if it is alkane gets preference. Chloro and all, they become substituent. You have to put them as prefix. What is the functional group? Two functional groups are there. One is ketone, one is alkene, right? Now, between ketone and alkene, ketone gets preference. So we have to start counting so that ketone comes first, and we have to take the longest chain, and in the longest chain you cannot neglect alkene because that is the important substituent. Okay, so when we see here, we count here 1 2 3 4 and 5. If something else longer chain was there, then we would have taken that longer chain, because once you select a functional group, other thing becomes just a substituent, so we don't have to compulsory keep the alkene. But if you go like that, we would have got only 4 carbons. Here we are getting 5 carbons, that's why we are keeping alkene. Okay, please understand, if we had something like this, like this, like this, like this, then we would have made this alkene as substituent, because once we already have functional group, anything else will be a substituent, right? And now what happens is, now 5 carbons are there, so we know it is pentenone, because on it is ketone, ene is alkene. Now we have this chloromethyl group, so chloromethyl is also there, so everything fits. Chloromethyl, pentenone, all of them are giving same, so I am not able to neglect anything. One thing is very clear is, we have to count the number of carbon atoms. So how I am counting? 1, 2, 3, 4, 5. Please understand, we have to count in such a way that ketone gets lowest numbering. So I am counting from this side, not from this side. So 2. So at position 3 I am having this chloromethyl. Oh, so all of them are 3. So this also went waste. Then let us look at alkene. Alkene comes at position 3. We don't look at 4, okay, whichever it gets closest to 3. So 3 in and 2 on, very clearly, because 2 on is there. So 3 in 2 on, this is the one, 3 in 2 on. So now one thing is very clear, it is either option A or option D. Now what will give us the right IUPAC naming? Now we have to talk about the absolute configuration of this isomers. So E and Z, you know, E is these two are geometrical isomers. E is like a cross trans, Z is together, it's like cis. So what we have to do is, we have to look at the two substituents on the either end of the alkene. So you are having one CH3, you are having one hydrogen, right? And here you are having one CH2Cl, here you are having C double bond O Me. Now what happens? I have to give first preference on the this carbon. So here you are having one CH3 and one hydrogen. We know we give preference according to the CIP rule, which is based on atomic number. So carbon has more atomic number than hydrogen, so this gets first preference, this gets second preference. Here what happens? Here we get carbon, here also we get carbon. So we go to next one. Next we are get chlorine. Here we are getting 2 oxygen, because double bond O is considered as 2 oxygen. So we don't care it is 2 oxygen or 5 oxygens. We look at the highest atomic number. Highest atomic number here is Cl, 17 atomic number. Whereas here it is just oxygen, which is just 8. So we don't look at it. This gets the first preference and this one gets the second preference. So now you see that this one and this one, they are on the same side. This 2 and this 2 on the same side. So answer will be D, Z, 3 chloromethyl, pent 3 in 2 on. Okay, I forgot to go slowly. I'll go slowly through this question. You should read it properly. Slowly I have written everything, whatever I said. I'll go slowly through it once again. You can pause it where you want. Yeah, moving to the next question. The pair of reaction depicted below are this. What are they? Are they enantioselective reaction, diastereospecific reaction, diastereoselective reaction, enantiospecific reaction? First, you have to understand what is difference between selective and specific. Selective means there are three ways routes possible. One of them will have lowest energy, so that will be major product, and then some other minor products will be found which has higher activation energy, so it needs little more energy. Whereas specific means there is only one route possible, so you'll get only one product. So in both the reaction you can see you're getting only one product. So damn clear it is specific. So answer has to be either option B or option D. Now what happens? You look at this molecule. These two are diastereomers. Why they are diastereomers? Because see this part. pH is coming towards the viewer. This pH is coming towards the viewer. So these two part are these two chiral centers are these two chiral centers are superimposable on each other. Whereas this part you see this OH, this is away from the viewer, this is toward the viewer. So this chiral center actually is mirror image. So overall what happens? These two molecules neither superimposable nor mirror image. So they are diastereomers. Even the product is exactly same what is in the reactant. So you are having these two pH on same side, so they are superimposable. These two part are mirror images, so overall neither mirror image nor superimposable. So two different diastereomers are giving two different diastereomers product, right? So that's why this reaction is diastereospecific reaction, right? It was as simple as that. Moving on to the next question. I will go slowly, you can read through all that. Next question. Which of the following species are aromatic? So what happens here is nitrogen is having positive charge. That's very interesting. That means some leaving group has left from nitrogen. Now, so if it is having a positive charge, that means there is one p orbital. Okay, there is one p orbital which will overlap. So what happens is this system is cyclic, this is planar and conjugated. Conjugated means all atoms should have p orbitals which are overlapping with each other. So all these are anyway having p orbitals because they are pi bond, and there is a positive charges, that means there is a p orbital and they all are shaking hand with each other. So they are all conjugated, and then finally it has to follow Huckel's rule. So how many Huckel's rule means? You should follow 4n plus 2. It should have 4n plus 2 pi electrons. So here how many pi electrons are there? 2 plus 2 plus 2, 6. So 4n plus 2. So when n is equal to 1, 4n plus 2 is 4 into 1 plus 2 equal to 6 electrons, right? Equal to 6 electrons. Whereas if you look here also sulfur is having lone pair of electron which will overlap with this pi orbital. So they are all conjugated. You see, each atom has a p orbital. It may not be p orbital but almost like p orbital which is overlapping with all of them, and therefore it is cyclic, planar, conjugated. And how many electrons? 2, because of lone pair 2 plus 2 4 plus 2 6 plus 2 8 plus 2 10. So when n is equal to 2, 4n plus 2 is equal to 10. So this is also following Huckel's rule. Now this all you can see there is no atom which is sp3 hybridized. All of them are sp2 hybridized. All of them have p orbital. All of them have double bond. So how many? So it is cyclic, planar, conjugated. But how many electrons? 2 plus 2 4 plus 2 6 plus 2 8 plus 2 10 plus 2 12. So it is not following 4n plus rule. It is following 4n rule. When n is equal to 3, 4n is equal to 4 into 3 is equal to 12. Therefore, this is anti-aromatic system and not aromatic system. So, species which are aromatic is only option A and B. So, answer is option number D. Option number D, because you are having both A and B, right? So, I'll go slowly, you can read all that. Next question. The following reaction involves a. So, you are having this and you are asking photochemical 10 pi system or thermal 6 pi electrocyclic ring closure, thermal 10 pi electrocyclic ring closure, photochemical 6 pi ring closure. So once we draw the mechanism, we'll know that how many electrons it is having, and we know it is electrocyclic reaction. So now you see the mechanism. Mechanism will be this goes here, this comes here, then this comes here, this comes here, and you get this structure. So how many pi electrons are involved? 2 plus 2 4 plus 6 8 plus 2 6 plus 2 8 plus 2 10. So very clearly it is either A or option C. Now we have to know it is photochemical or thermal. So one thing you should know, one formula, just if you remember, 4n h nu dis, everything else follows. So 4n h nu is dis, 4n plus 2 thermal is con, it will be opposite of it. Now 4n is h nu is dis, so 4n plus here, so 4n plus 2 h nu will be con, right? And because 4n plus 2 h nu is con, 4n plus 2 thermal will be dis. Now here 10 electrons are there, so it is 4n plus 2, right? Because it is 10, so when n is equal to 2, 4 times 2 is 8 plus 2 is 10. So now we know it is 4n plus 2 systems. Once we know that how the ring closure is happening, it is happening by disrotation or con rotation, we will be able to tell it is thermal or photochemical. So if you see that this stereochemistry is gained by con rotation, then we will know that this reaction happened under photochemical condition. Or if you see that this kind of stereochemistry you are getting, this kind of stereochemistry in the product you are getting by disrotation, then you know that this reaction not undergone by photochemical but undergone by thermal conditions. Okay. So let us look at the reaction. Let us look at the reaction. One second. Yeah. So let us look. Conrotation means orbitals will move in the same direction, either clockwise or anti-clockwise. So this is the pi system. So imagine we are rotating both of them clockwise, so that this moves like that, this moves like that, so that this pi bond comes as this plus face of the p orbital comes here, and plus face of this p orbital comes, and you get a sigma bond like that. So when you rotate like this, what happens? See, you have to understand this was in plane, this all these bonds are in plane. So in rotating it like that, what is happening? Hydrogen is coming towards the viewer, this is going behind, so hydrogen towards the viewer. Whereas this, when this is rotating, you see hydrogen was on front, on top, not front, sorry, on top, and pH is down. So when you're rotating it like this, what happens? You're pushing hydrogen behind, you're just rotating 90 degrees, okay? You're pushing hydrogen behind and NPHM is coming front. So you're having this. Was this what you're getting? Here you're getting nitrogen away from the viewer, hydrogen towards the viewer. What you got here? Nitrogen towards the viewer, hydrogen also towards the viewer. So this is not what is expected. Now let us try conrotation when both of them move in anti-clockwise direction. So this p orbital is coming anti-clockwise. So when you are rotating like that, you see this hydrogen is below. So in rotating like this, what is happening? You're pushing hydrogen behind and pulling the ring front. So hydrogen is behind, and when you're rotating this also anti-clockwise, like that you're pulling, you understand, just 90 degrees. So this hydrogen was in plane, so you're pulling it outside 90 degrees, and this NPH is going inside. So you're having like that. So what happens? You got this part correct, NPH away from the viewer, but this hydrogen is also away from the viewer. What we need is this hydrogen towards the viewer. So clearly this reaction is not by conrotation. Now this rotation, one of them will go clockwise, one of them will go anti-clockwise. So imagine this is going by clockwise, this is going by clockwise, and this is going by anti-clockwise. Then what happens? You're rotating outside, so H is going away from the viewer, inside. You're rotating it inside, so H is going inside and NPH is coming outside. So getting this, but product did not show that, and the answer was N was away from the viewer, H is towards the viewer. So now if you rotate this in clockwise and this in anti-clockwise, then what happens? You're rotating inside. So H is coming outside. Clear? This ring is going inside. Whereas this we are pulling it like this. So what happens? H is coming out, N is going inside. So getting this, this is the product. So once we know it is this rotation, we know 4n plus 2, this is thermal. So it is, so the answer will be thermal 10 pi electrocyclic ring closure. So answer will be option number C, right? So I will go again slowly. Please go through it, pause it whenever you need. Now this question 28 is very easy. Number of signals observed in the proton decoupled 13 CNMR. So you see all these rings are identical. They are all attached together. So one ring, if you find out how many different kinds of carbon are there, we get the number of peaks. So you know these two are same, these two are same, and these two are same. So we'll get 3 peaks, and that will continue in all of them. So answer is 3, right? Last question. The correct statement for the following chemicals in column P. So easiest one, let us see. This is glycerol. So you know vegetables or oils are triglycerides of fatty acids. So fatty acid is there, and this is the glycerol. And, fatty acids, carboxylic acid, long chain carboxylic acid, and they form esters with triglycerides. So very clearly B matches with your 3. And then what happens is lignin, sorry. Lignin is a polymer which has molecule C. So lignin, we have to just know the structure. There is not much chemistry, you have to just remember this. Lignin has this as monomer. So these two matches, and xylose has pyrene ring. So this matches. Therefore, answer is option B. Okay, this answer is option B. So with this I finish the CSR question papers. Thank you very much.